So a little bit about our company. We're a California company. Clear was formed 10 years ago in Northern California. It was an outgrowth of a company that sold diesel engines and serviced and repaired them, and a group of UC Berkeley PhDs in mechanical engineering who knew about the science and technology of the types of things that you need to put on tailpipes and clean the diesel engines. We're a privately held company. Recently moved the headquarters to San Diego, but we have R&D activity in the Bay Area. 55 employees. Although when we look at the entire jobs impact, and that's an important point of our business, it's not like installing solar panels or doing retrofit siding. Those are really job creators, and because you're doing the work locally, the jobs have to be local. So when we add our entire workforce involved in retrofit, it gets up into several hundreds. And if you look at the entire industry and the activity in California, we're in the many thousands of jobs. And to date, over the last 10 years, we've been successful in installing more than 14,000 of these devices. So the technology is well proven and is working every day. Just a list of our products. We lead the industry, the retrofit industry, with the card verifications that were mentioned. That is the gateway to be able to sell. It's an approval from their resources board that the products are viable, durable, and robust. And I think it's worth mentioning the mission statement because it's important. We fall between, and sometimes in an awkward spot between the owner of diesel equipment who wants to continue doing their job and doing business as usual, and the air quality side that wants to clean up the air. And our mission actually covers both. We want to maximize the useful life of the engine or the vehicle by providing state-of-the-art technologies. You know, construction equipment is very expensive. It can standard things in the picture I'll show you can range between $100,000 up to $1 million. So very, very expensive capital outlay to do construction work. What we offer is a very cost-effective solution to allow that equipment to run its useful life while ending its emissions life. So we clean up the emissions but let the equipment run, and that's really what Clear is all about and what retrofit technology is all about. A couple of slides on particles, just to put in perspective how small the particles we're talking about. On the upper left is a slide showing a human hair and a grain of sand, and then the little blue spherical balls represent PM10, and then the red ones represent PM2.5. So you get a sense of how small these really are. And you hear oftentimes that, well, my diesel engine isn't polluting because I don't see black smoke coming out. It's probably polluting even more. There are trillions of tiny particles coming out. They're so small they're not visible. And they are the ones to be more concerned about, frankly, because the visible ones will fall to the ground. The smaller ones will stay airborne and travel further distances and can get through the body's natural defenses like your nose and your upper trachea and get down into the bloodstream. So very, very small particles. On the right is a depiction of a particle to talk about. It's not just a piece of carbon, although that's an important part, and I'll talk about that more in a little bit. But these are carriers for lots of other things that are unhealthy. Toxics, which tend to be hydrocarbon-based, metals, sulfur nitrate byproducts of the fuel, and then ultimately the aluminum core. So there's a lot of stuff in a diesel particle. None of it's very good for you, so getting rid of it's the desired thing. And the experts that know a lot more about than I, but the fact that there are a lot of recorded health impacts on an annual basis because of diesel PM. Numbers are high, so the driver to reduce the pollutants is high. And I was going to make one more comment on the last slide and this slide. A lot of diesel particulates, so we get in our mind that they're a ball, just this little tiny black ball, and the reality is there's a lot of surface area to them. And since it's Halloween, a funny story, a few years ago we had a company Halloween dress-up day. We don't do that anymore. But one of our engineers came as a diesel particulate, and he glued black balloons all over his body to show this surface area. It was an inside joke, but it went over well. But there's another co-benefit to diesel particulate besides the health side, and that's black carbon. And the impact of black carbon on climate change is really emerged in the last few years as it's being a really strong actor. CO2 is really the benchmark climate change greenhouse gas pollutant that people talk about, and that's somewhat of an unavoidable byproduct of combustion. The more fuel you burn, regardless of what type of fuel it is, the natural byproduct and what used to be the clean byproduct is CO2. That's still probably the primary cause. CO2 is very long-lived. Then you have methane and hydrofluorocarbons and other things that contribute. Well, black carbon is emerging as a very strong global warming agent, primarily because of its ability to absorb the radiation wavelengths that contribute to the warming. So the good news is the technologies to reduce diesel particulate, which is primarily comprised of black carbon, also take care of the climate change issue. So it's a 2-for-1. And the other point was the technology that we use with diesel particulate filters filter out not only the PM10 and PM2.5 that has been regulated, but they also do filter out the ultrafines. So I think the fact that the technology already exists today to go after ultrafines, as the science around the health impacts of ultrafines becomes more known and regulatory frameworks evolve, you'll have a mature solution in hand should you choose to go after those. And you're getting ultrafine control today anyway. A little bit about the technology. The idea of a filter is very simple. Particles in the exhaust stream go into this filter body, which in practice looks like a muffler. It's on the tailpipe, and they're physically separated. In other words, there's a membrane like the one below that's got fine enough pore structure that the small stuff stays behind and the gases flow through. And that's a very simple concept, and it's very well proven. The level that you can filter is 99% or greater, maybe 99.9% of all particles get captured. Very effective. The challenge is on the right-hand side, which is once you've collected the particulate, what do you do with it? The process of dealing with it is called regeneration. It's generally combustible. It can be converted into CO2, which is relatively much more benign than the carbon. And that requires a number of approaches, whether it's catalytic reactions to oxidize the carbon or thermal heating. We have products that use something as simple as an electric heater. You drive your bus or truck around by day, you fill up your filter with black carbon, and at night you plug into a wall. The utility rates are low, and over 4 hours you bake out the filter, much like a self-cleaning oven. So that's a very simple approach, but so there's every step in the range from that simple collect it during the day and clean it out at night to collect it on the go, which is what we call passive regeneration. Without being asked, but I'll say the cost of these devices tends to range between $10,000 and $20,000, and the first response is, how can something as simple as a filter cost $10,000 to $20,000? And the answer is, one, it's designed to survive in a very tough environment, and two, the technology to keep it clean and manage the regeneration is really where the costs come in, because there's a lot of complexity to that. These devices really work. There's an organization in the East Coast called the Clean Air Task Force, and they've done a lot of in-field monitoring of diesel particulates, and they did a study looking at particle emissions from a piece of construction equipment with and without the filter. And I think you can see the pink line on the left. The particle numbers over time are high. They're not constant, because as the engine works, more particles come out. So that's the left side is the baseline with the filter installed. You get near zero emissions afterwards. So very effective control technology. I'll just show some of the pictures of the Clear installation portfolio. We've done maybe 1,000 pieces of off-road equipment. The on-road has really been where the market has been, and with CARB regulations driving on-road retrofits starting back as early as 2003. That the on-road market has matured. The off-road has come a little bit behind it, but we've done a number of pieces, and these are typical types of machinery you'd see on a construction site: an excavator, a loader, a scraper. These scrapers are the $1 million pieces of equipment that have a 20-year life. They work very hard. The technology hasn't evolved so fast that buying a new scraper is allows you to do a lot more work than a 10-year-old scraper. So the good business operators to do construction would like to keep their assets running as long as possible. And because of the high replacement costs, it makes sense to do so. So this is an example where where retrofit makes a lot of sense, because buying the latest, greatest doesn't get you as much. And then on the right, it's a picture of the plug-in filter on a motor grader. So that just gives you a sense of the range of equipment that we can retrofit and that our industry can retrofit. And if you start looking at construction sites, these are very common types of pieces of equipment. And the last thing, I think the other speakers will talk about more, but what promotes retrofits and regulations? The Air Resources Board has been the leader. The plans to heavily regulate the off-road market have been delayed a bit because of economic downturn, and also less of a demand in the near term for some emission reductions. That being said, the regulations will start to take place in about 2 years. So when we say delay, we don't mean indefinitely, we mean 1 or 2 years. In the meantime, local agencies, particularly South Coast AQMD, has got programs in place to encourage early adoption of retrofits. And then there are a number of local programs that I'm eager to hear about today, but the MTA is one that is adopting clean construction ordinances and things like that to really focus the emission reduction where the activity is. That is to say, when we're going to do construction, we need to make it clean. You can't argue that there's no economic activity because you're doing construction work. So the cost of cleaning up is small relative to the overall cost of the product. So that's the introduction on the technology side, and at the appropriate time I'll take any questions. Thank you, Brad.